I'm gonna show you the process of creating antivirus step by step. I've always wanted to do such a project, so I thought, why shouldn't I share it with you? So here it is, a new mini-series on my channel, and the first video, when I will show you a user interface made fully in Python, connected to the simple antivirus engine that allows you to scan files inside the specified directory, or even a single file if you wish. Okay, so without wasting any time, let's jump right into the user interface. What you now see on the screen is a UI made with tkinter, which is a Python library designed for making UIs, basically. So I know it's not the prettiest, it was my first time using this library, but it needs to be functional, not prettiest, not pretty. So yeah, maybe it will be pretty after the end of this series, I don't know. We'll see, I guess. So the first button at the top is switch to directory upload. By clicking this button, you can basically switch between single file upload and directory upload. With directory upload, you make the antivirus scan the whole directory. I think it's pretty logical and self-explanatory. But let's go further. This image here, once you click it, a file explorer will appear. You can choose a file that you want. Let's go with Microsoft Word document, because why not? You can see it displays a path to the chosen document, to the chosen file, and once you hit upload, it will connect to the backend, and backend will return the answer to our question, is this file malicious? And as you can see, there are no calls that it's malicious in any way. I'm not gonna explain what this means yet. This is backend stuff, so this will wait a minute or two. Let's go with the UI code first. So going from the top, we have our imports here. We have a theme specified, which is superhero. We have our title, we have geometry, which is a resolution that our window starts with. You can resize it, of course, but yeah, that's the base resolution. We have a file path variable initialized, and we have upload type flag. This is gonna be used for specifying if we wanna upload the file or if we wanna scan a whole directory, but you're gonna see it later. Now let's skip these functions right now and go to the toggle button, because this is just a label. This is the best AV in the world. Yeah, so this is just a text label, nothing interesting. But here the toggle button has a first thing, you initialize a button like this, or an object in tkinter. You initialize it like this, and you use .pack to pack it into the interface itself. If I were to comment this, you wouldn't see the button on the screen. It would not appear. But okay, it appears with an initial text of switch to directory upload, with a boot style secondary. By the way, all of these parameters are in the tkinter documentation, of course. And if you want to know more options of boot style, what can you pass here, what else than secondary, I'm gonna link you the whole documentation in the description, so go check it out. And the most important parameter is command. And the command is equal to the function defined here. So let's check out this function. This basically means that once we click the button, this function will execute. I think it's quite clear. So this function modifies the upload type variable, our flag, sort of. If the upload type is file, we change it to directory, and we change button text to switch to upload file. And if the upload type is not file, so if it's directory, basically, we change it to file, and we change text to switch to directory upload. Thanks to this, we have this functionality that you can click the same button and it just switches, you know. Now, next thing is our file label, which displays, which displays a path to the file that we just chose. All right, and if we didn't choose a file, it displays no path selected. No path selected, but that's in a second. Here we are loading the image that we are then clicking, and here we are initializing an image button with a label image equals this image. So those two commands, those two lines of code, basically they create for us a button in form of an image. And here we are binding this function sort of to our button like this. File dialog function. Let's check this out. File dialog here. All right. So again, we are checking what the upload type flag has. If it's a file, we are using the file dialog function with ask open file name. As you can see, this basically opens a file explorer and asks you to choose a file, and if this is not if this is not a file, if this is a directory, it will ask you to choose a directory. All right, you will not be able to choose a file here, and you will not be able to choose a directory here. And what's next? We are modifying the file label, this thing, and we are basically passing here either a path or no path selected. All right. This will be displayed, by the way, if you hit the upload button, which I'm gonna show you in a second, without going through this file dialog process. All right. And the my button, which is basically an upload button. I might wanna change those names later, but for now we are using the execute engine command with file path. Okay. File path is the path that we just specified, of course. But now it can be either a file path or a directory path. You know the idea. And execute engine. Here is the execute engine function. So if file path is present, we will be running this process, which is engine.exe, which is our antivirus compiled antivirus engine. And this engine takes one parameter, which is the file path. So we are passing this parameter here. We also want to have the std out. We want to have the output of this engine, so we can print it to the user, and we do that inside output text. So this is again a label that just says scan results, and the output text is here. And as you can see, we are passing result.stdout.decode. We are passing the captured output from engine to this output text. Before we go into the engine itself, you need to know how antiviruses work. And I mean the detection methods. There are a lot of ways for antivirus to detect malware. The most popular are, for example, signature detection, which involves comparing a file against a large database of malware signatures. There is heuristic analysis, which involves monitoring behavior of the potentially malicious file. But this is they are fairly complicated. I mean, okay, signature-based detection might not be very complicated to implement, but heuristic analysis is. By the way, that's like a side note. This is my end goal for this series, to make a simple but yet effective heuristic analysis algorithm. But that's like for the further videos. There is one more detection method that I really like, that is easy to implement, that is popular. It's called YARA. YARA, or yet another ridiculous algorithm, is a framework dedicated to large-scale pattern matching. This framework allows you to create rules based on which the algorithm can identify the malicious samples. I'm not gonna explain how you create those rules. There are plenty videos about it already on YouTube, and I'm sure that if you are not brand new to the cybersecurity field, you have already heard about YARA rules before. So let's not focus on that. Let's focus on how we can implement this whole YARA rules and the YARA algorithm inside our engine. Thankfully, creators of YARA made an API for it, and as we are using C language, this API is exactly for C language, so it's a perfect solution for us to automate the whole process. Now, once you understand what YARA is and you have everything installed, let's start checking out the engine code. As you can see, we are requiring a parameter, which is the file path from the user interface, right? We are catching it to the file path variable. The directory path, as you can see here, is an hard-coded path to the rules folder. Rules folder contains a bunch of .yar files, which are YARA rules that I've downloaded from various GitHub repositories. This folder will be shared in my GitHub repository, in the repository for this project itself, link in the description of course, and with the next videos that when I will be upgrading this antivirus, the upgrades will be available also on this GitHub repository, so make sure to click this star button so you don't lose it anywhere. Alright, so once we do this, once we have hard-coded path with rules inside, once we have a file path from the GUI, we want to initialize our YARA algorithm. We do this with YARA initialize function. Also make sure to hashtag include YARA.h library. Okay, if it's succeeded, we print successfully initialized YARA. Then we create what's called a YARA compiler. We will need it to first compile our rules from these .yar files so they are usable inside algorithm. YARA compiler, we create a compiler of type YARA compiler. First we assign null to it. YARA compiler create, this function creates a compiler and saves it in this object. Alright. Next thing is opening a directory. We open the directory path, which is our directory with rules, and if this succeeds, we are then going through this directory, getting each and every YARA rule and adding a file to our compiler. So we are entering directory, taking the first one, adding to the compiler, taking the second one, adding to the compiler, taking the third one, adding to the compiler, and once we add everything, we are ready to get the rules. Let me delete this because this was the error I was getting before, but it's not happening anymore, so it's useless. All right. I don't really want to go line by line because I was already explaining how this works in my ransomware video, link in the description also. And this is a part, these are functions from the Dirent, am I right? The Dirent library, Dirent.h. This is, I got this header file and this library from a GitHub repository, and also link the description. There will be a lot of links in this video. Yeah, so just download this file and copy it to your project, so you have it in the same directory as your engine.c. Yeah, and include it at the top, of course. But the most important here is this function YARA compile add compiler add files. We are adding, we are passing as a first parameter our compiler object, and as a second parameter a file, an opened file with an open file object opened with fopen function. Yeah, and the last two are null. You can read in the description what they do, but they are not important for us. Okay. And as I said, we are, once we add everything to our compiler, we then want to actually use it and get the rules and save them in rules object, YR rules, like this. Compiler get rules, first parameter our compiler object, and the second parameter an object that we want to save rules at. And the last function, check type. Check type function takes file path and rules object and checks if we specified a file path or a directory, because you remember our UI doesn't do this check. It just allows us to specify one or another, but it just sends it to the engine, and it doesn't specify if it doesn't send it and specify if it's a file or a library, so we have to do it inside the engine itself. Check type, we are using this very cool function s_is_reg with pathstat.stmode, like this. Pathstat is a structure of type stat. Okay, and if this is a file, we are calling scanFile function, and if this is the directory, so s_is directory. If this is a directory, we are calling scan directory function. Else unknown file type, else error getting file status. This should be clear. All right, so as you can see, we have two functions left, void scan file and scan directory. Let's go with scan directory first, because this is pretty much just a function on top of scan file. This is a recursive function that enters a directory and executes a scan file a couple times on every file inside this directory and ends just like this. So as you can see, we are, while we see a directory, while we see a directory, we are going yet inside, deeper inside, and calling scan directory one more time, because in every directory, then there can always be another directory. Pretty logical, but we want to go as deep as we can. We want to scan every file on desktop, for example, every file on desktop, every file inside every folder on desktop, and so on and so on. By the way, this is exactly the same function from the ransomware video. This is exactly the same. I just changed the names here. And if we stumble upon a file, we call scan file. So we call scan directory once we see a directory and scan file once we see a file. But basically this function ends up calling scan file at some point. I mean, if there are no files in the specified directory, it won't call scan file, but you get the idea. And actually last function, last function, I don't know how many times I already said last function, but this is the last function. And definitely the most complicated one, because it has so many lines. So many. YR rules scan file. Fortunately, the YARA API provides a single function that gives us what we need. First parameter is our rules object. Second, a path to a file that we want to scan. Third is a scan flag report rules matching. All right, what is this? Let me show you. In the YARA documentation, here we have the types of flags that we can specify, and they basically allow us to modify the response that we get, because we can get as a report, as a response, we can get all the rules that are not matching the file. We can get only the rules that are matching the file. We can get matching and not matching. You know the idea. That's why in the user interface, when I hit upload at the beginning of the video, you saw a bunch of prints that the rules were compiled. Prints from this function, compiled rules and a path to a rule. You saw all of that. But after the scan was done, you only saw the message that this scan finished. That's because no rules were actually matching, because I specified this flag that I only want to see rules matching. Therefore, there is pretty much no noise if we are not dealing with a malware, because there is like more than 100, definitely more than 100 rules, if I remember correctly. Yeah, so go with rules matching here. I mean, I went with rules matching, but you do what you want. Scan callback, I will tell you what this is in a second, and to nulls. So scan callback is a function that I took straight from the documentation again. It's somewhere, should be somewhere in the documentation. I don't want to waste time searching for this right now, but you can just copy this, and it basically handles the whole callback, handles the response. So as you can see, in case of what flag we specify, it prints for us the response. Yeah, and I think that's pretty much it. That's pretty much the whole engine as for right now, because this is just a single detection method that we are working with. My plan is to expand to first make it protect you live as Windows Defender does. Remember that whenever you download a file, you have to, whenever we download a malicious file, for example, a payload from Interpreter, we need to disable Windows Defender because it deletes immediately, this file immediately. So I want to implement a functionality like this in a future video. I want to implement a quarantine or the file deletion, deletion or the deleting function itself, and the heuristic algorithm, and also work on the UI. Those are 4 things that I want to do before I end this project for sure. Maybe I will come up with something cool. Maybe you will come up with something cool. So definitely point me to this in the comments. And now let me finally show you how this engine works with a malicious file. This time you already saw the how it works with a safe file. It just scans it and does nothing, but how it will handle a legitimate malware. We're gonna go with well-known interpreter TCP, reverse shell, MSF Venom. This is the command to generate it. You generate it and save it as payload.exe, right? I have it on my desktop already, so I'm not gonna run it. Let me transfer it to my Windows PC. Okay, I'm gonna use Microsoft Edge for that because Chrome is actively blocking my payload.exe from downloading, and Microsoft Edge is not. Like you can see, I'm using Python HTTP server because there is something wrong with my VM and I can't like drag and drop. I don't know why, but I'm too lazy to fix it. But okay, here it is. Payload. All right, so once I have the payload, let's go to the VS Code, open up a terminal, and launch a GUI. Let me zoom in a little bit so you can see better, like this maybe. Should be good. Should be good. Okay. Directory upload? Nope. We want single file, payload, open. As you can see, payload.exe was selected and hit upload. Now we wait a second and a bunch of results are here. A lot of rules got triggered. Pretty much all of them are, talking about reverse HTTP, reverse TCP, shell reverse TCP. Is it anything mentioning? Yeah, is it PE64, Windows executable? What more? Do you have anything more? Do we have like a interpreter mentioned somewhere? I don't think so. But yeah, you see it works like this. But let me show you the directory. I'll show directory upload. Let's go with the decrypt Chrome passwords. This is a malware from the previous video. Let's select this folder and hit upload. We wait a second again. Well, this time little more seconds, because it needs to go through every file inside this directory and every file inside each directory that is inside the root directory. So I'm gonna meet you once it's finished. And it's done. You can see UI needs to be a little bit adjusted for this, because we are getting scan finished for each file that was scanned, but we have some checks. Some rules got triggered. Now, once you have this, you can of course go to the rules folder, check out more information about this rule, because every rule has some metadata with something said about it. For example, the author, some links to articles and those kind of stuff. This is a very cool feature in YARA rules, actually, because it allows you malware identification. It makes the identification way easier. For example, pwn mockup. I have no idea what pwn mockup is. I can Google it. I can go to YARA metadata, check out, maybe something is there, maybe not, but yeah, another resource basically. So that's how it's done. Thanks for sticking till the end. Make sure to hit this subscribe button so you don't miss any new content. Leave a like, and if you have feedback or maybe some ideas what can I do better with this project or my channel in general, leave them in the comments below. See you soon.